In this video, I'm going to go over how we can transform functions. So we'll do that by going through a series of examples. The first says, describe the transformations that produce the graph of f of x from the graph of its parent function. So for number one, we have f of x equals 1 over x plus 2. The parent function here would be 1 over x, and the graph of that parent function is just this rational graph with those asymptotes. And so anytime we have a constant getting added or subtracted, that corresponds to a vertical shift. So we would start with y equals 1 over x, shift, we'd say up 2 units. So we don't need to graph this, but if we wanted to, everything would just shift up 2. So the horizontal asymptote would just shift up 2 units, something like that. All right, the next one we have the cubing function, which is x cubed. So we have more transformations here. We have this 2 getting added, we have this plus 1, and then I have this negative 1. And so let me color code these so maybe it's easier to follow. So when you're applying transformations, you always want to start in the inside, the innermost part of the function. In other words, the thing that's closest to x, and work your way outward. So the first thing I'll do is I'll look at this plus 1. That is a horizontal shift. Any horizontal transformation is kind of the opposite of what we would expect it to be. So this is a plus 1 horizontally. So this is going to be left 1 unit. Next, we have this negative value here. And what that is going to do is going to flip the function vertically. We say that this reflects vertically. That, in other words, that's just going to flip that graph upside down. And then this plus 2 is going to shift up 2 units. All right, so if I want to think about what that graph looks like, well, the original cubing function looks something like that. So the new graph, see if I can do this. I'm going to shift that left 1 unit. I'm going to reflect vertically. So now that graph is shifted left, and now it's flipped over. And then I'm going to shift that up 2 units. So that would look something like that. It's hard to be precise, but that's the general idea. The next one, we have this cube root function. So the parent function is going to be cube root of x, and that graph looks something like that. And let's go through the transformations. We have this negative here. That's going to reflect horizontally. In other words, it's going to reflect about the y-axis. So that graph now would look like that after the reflection horizontally takes place. Moving outward, I have this 2. This is going to stretch the graph vertically by a factor of 2. Vertically by a factor of 2. And what that means is all of the vertical components, in other words, all the y values, are going to get multiplied by 2. So if I was just stretching this vertically, now that graph would be something, let's try that again. It's going to be something steeper, something like that once it's stretched vertically. And again, that would be if I don't do any horizontal reflection. Okay, and then the last transformation is I have this plus 4. That's going to shift up 4 units. Okay, so putting it all together, the new graph, I'll just do it all together here. So reflect horizontally, stretch vertically by a factor of 2, and then shift up 4 units. So it's going to be something like that. not as many squiggles This is hard to do on the iPad screen. So something like that. Okay, and then we have one last one. This parent function is the absolute value function, which looks like this. And then we have two transformations. We have this 1/3, and what that is doing is that is multiplying all of the horizontal factors by 1/3. So when we multiply something by 1/3, it's getting compressed. So how do I want to write that? Well, I'm remembering how we do this. The horizontal factor, what happens is it's the opposite of what we'd intuitively think. So just like we saw up here when I did x plus 1, that was a shift of left 1 unit. When I multiply inside the function by something that is between 0 and 1, that is actually going to stretch out the function. So we would say stretch horizontally by a factor of 1/3. Okay, and then that -2, that's going to shift down 2 units. Okay, so this new graph is going to be stretched out a little bit wider. Oops, and I want to shift that down 2 units. So it's going to be like this. Okay, a wider V shifted down. Okay, moving on. Graph the function using transformation. So this is kind of what we've been doing. I have the squaring function. So that's the parent is going to look like a parabola. And then this 2 says move left 2 units, reflect vertically, and then down 5 units. So I always pick a point, and then in this case, let's pick the vertex. I'm going to move it left 2 units. I'm going to flip that upside down. So my graph would look like that. And then I'm going to move it down 5 units. So 1, 2, 3, 4, 5. So this is what that function f of x would look like. Okay, and then 2 more. Now we're given a description of what's happening to the function, and then we want to come up with the equation. So write the function for f of x equals x cubed, shifted 4 units left, stretched vertically by a factor of 3, reflected about the x-axis, and then down 2 units. So we'll say 4 units left is going to be x plus 4 cubed. Stretch vertically by a factor of 3. We're going to put a 3 in front. Reflected about the x-axis, so that's a vertical reflection. So this, our negative goes there, and then we're going to go down 2 units. So that's what our new function, the equation of our new function would look like. And then this last one, we're going to start with square root of x, 3 units right, reflected about the x-axis, and then shifted up 1 unit. So this will be square root 3 units right, that'll be x minus 3, reflected about the x-axis, and then shifted up 1 unit. So that's what it will look like.